Right, we're looking at stratified sampling, and to start off with I just want to do a real basic example to get you thinking about what this actually means. So, let's say in a school there are 100 students. Now, let's pretend that this has been made up of, there are 70 boys and 30 girls. Now, if we're going to take a stratified sample, what that means is we're going to get a sample that represents the proportion of boys to girls. So let's say we're going to take a sample of 10 students. What that would mean is that we would have 7 boys in our sample and 3 girls in our sample. Hopefully that gives you an idea of what I'm talking about in these next examples that are a little bit more complicated, but essentially you're trying to find a sample of students or people or whatever you're looking at that represents the proportion in the original data. So let's have a look at a more exam style question. So here we have, there's 300 students altogether in the school, and it tells us how many year 7s, year 8s, year 9s and year 10s there are. And we want to take a sample of 50. So we're taking 50 students out of the 300 students. And what I want to find out then is what percentage of the total are we actually wanting to find. So to change 50 out of 300 into a percentage, all I need to do is type that in on my calculator. Okay, so once I've typed that in, that comes out at 0.16 recurring. Now, to change that into a percentage, I could work with 0.16 recurring, but what I think I'm going to do is just round that, and let's say that what we're looking for then is 17%. So the sample that I want is 17% of the total students. So I need then 17% of the year 7s, 17% of the year 8s, and so on. So how am I going to calculate 17% of those year 7 students? The quickest way to find 17% is actually times in 72 by 17% as a decimal, so that's times in by 0.17. So when I type that into the calculator, 72 times 0.17, that comes out at 12.24, and remember we're talking about people here, so we're going to say that's 12 people from year 7. I then need to find 17% of the year 8 students, so we've got 108 year 8 students, and I want 17% of those, so I'm going to times that by 0.17, and that'll find me 17% of the year 8 pupils. So that comes out at 18.36. So remember we're talking about people, can't have 0.36 of a person, so that'll be 18 people from year 8. Continuing on for year 9 then, 66 times 0.17 will find me 17% of the year 9 pupils. That comes out at 11.22, which we'll say then is 11 year 9s. Finally, the year 10s, that's 54 times 0.17 to find 17%, which comes out at 9.18, so we've got 9 pupils in year 10. Now, a really good thing to do here is to check that that makes sense. So I wanted a sample of 50 pupils. Do I have 50 pupils when I add these all together? So 12, add the 18, that's 30, plus the 11, 41, and plus the 9, 50. Yes, so they all add up to 50, so therefore that must be correct. Now, I did notice here that that says non-calculator. Ignore that because that would definitely be a calculator question. Okay, let's have a look at the next one then. This one, you've got to apply what we've just learnt there to this question in order to fill in the gaps essentially. because we have 400 people and a stratified sample has been taken. So what we need to figure out then is we have all the information we need for this 18 to 39, okay? That's just the age of the group. So a sample of 20 students was taken out of the 100 students in total. So the first thing I need to know is, so what percentage was actually taken? So what is 20 out of 100 as a percentage? Well, that's nice and straightforward, it's 20%, isn't it? So the sample that we're taking is actually 20% of the original amount. So if we're looking at the juniors, we have taken a sample of 15 juniors, and that is going to be 20% of the original. So the original amount would be 100%, and what we need to think of then is, if I have 20%, how do I get up to 100%? Well, I times by 5, don't I? So I'm going to times by 5. Now, if you're not sure on how to do 15 times 5, you could always get your grid. So you've got 10 times 10, and 5 makes 15, sorry, and then times it by 5. So 10 times 5 is 50, 5 times 5 is 25, and then you're going to add those together, which is going to give you a total of 75. So I now know for my juniors there was 75 members. Okay, now then I'm going to get rid of that so I've got plenty of space, and let's look at the age category of 40 to 59. So this time I know that in total, so 100% of that group is 120 people, and we know that our sample that we're looking for is actually 20% of that. So if I know 100% is 120, how am I going to find 20%? Well, to get from 100 down to 20, I divide by 5. So therefore I need to do 120 divided by 5. Now I could use a bus stop for that. So 5 goes into 120. 5 goes into 1, it doesn't. Carry over the 1. 5 goes into 12, twice. Carry over the 2. And 5 goes into 20, 4 times. So my answer here is 24. Now, what I need to find next is how many members were actually in the age category of seniors. So, in order to do that, I need to look at that key information that I circled originally. So we said that there was 400 members altogether. Now currently we have 75 juniors, 100 people in the age category of 18 to 39, and 120 in the age category of 40 to 59. So at the minute we have 5 add nothing, 5, 7 add nothing, add 2, 9, 1 add 1, 2. So we have 295 of our total people, and we have 400 people. So that must mean then that we need to do 400, take off that 295, which gives me 105 people left over. So I have 105 people left over, and I need to either find 20% of that or add up how many are in my sample at the moment, so 15 plus 20 plus your 24, and find out what 20% of the 400 members is, and then work out the difference. I'm going to just find 20% of 105 to keep it nice and straightforward. So we know 100% of the seniors is 105 people, and we're trying to find 20% of those seniors. So to get from 100 to 20, I divide by 5, and therefore I need to do the same to the other side, divide by 5, and I can do my bus stop for that. So I've got 105, 5 goes into 1, it doesn't, carry over the 1, 5 goes into 10 twice, and 5 goes into 5 once. So that's an answer of 21. And now I've got all my table filled in.